Grade 11 Pre-Cal, Lesson 18, Graphs of Quadratic Functions 2. So what we're doing is we're continuing on with what we learned in the last lesson. This one we're going to talk about, graphs that open wider or narrower and then open up or down, and then we're going to move some stuff around. Okay, so let's take a look at the first three. So we have y equals x squared. That's our standard one. That's the black line here, right? So we start at the origin, up 1 over 1. Over 1 up 1, then the other one is over 2 up 4, over 3 up 9, and then again because of reflection, right, it's the same in the other one. Now what happens when we chuck a 2 in front of this? Well, what happens is you can actually see the graph goes up much faster. It's taller and skinnier. So if the number is like a 2, 3, 4, 5, or 6, right, it's going to open quite a bit faster. Now what if it's a fraction, something between 0 and 1? And you can see the green one, it actually goes up slower, so this one's a little bit wider and shorter. And that's what our rules down here say, right? If it's greater than 1, the graph is taller and skinnier. If it's less than 1, the graph is shorter and wider. Basic concept there. Okay, next page. What happens if there's a negative in front of here? Well, it's simple. Instead of it opening up, it now opens down. But the pattern is still the same. Sorry, this one's a little off here, but it goes through 0, 0, right? That's our vertex. And then it goes over 1, down 1, over 2, down 4, over 3, down 9, and so forth, right? Because we're just squaring it. So the same pattern that was above is now just below. Really simple on that one, okay? Next one here. Sketch the graph of y equals negative in front there, and then x minus 2 squared. So what we got to do is we got to figure out the vertex. Well, the vertex is really quite easy in this case. What number do you plug in here to make that equal to 0? 2. So that is the 2 of our vertex. That's the x value. And then we have a plus 0 over here. We don't write it in, but it's a plus 0, so that's the y value of our vertex, right? So then we can put our vertex there. Bang. Now, this is negative, so we know instead of it opening up, it opens down. And it's a 1 there, so it's the standard pattern. So from this vertex point, over 1, down 1, over 2, down 4, over 3, down 9. And then it's a reflection in both axes. So now that we know the vertex, we know a couple things. We know the axis of symmetry, which is just the x value of the vertex, and x equals 2. This one is a mountain, right? Mountain, so it looks like Max is living on the mountain, so this is a maximum. Right? So the maximum is just the y value of the vertex, so y equals 0, opens downward. The domain, both of these, I'll put both, right? Interval and set notation. So interval notation, right? It goes negative infinity to positive infinity, or we do it as x is an element of R, right? It's all values, all real numbers. Range is negative. Remember, we always start with the negative. So we start from the negative and get all the way up to 0 and stop, but it includes 0. So that's why on interval notation, you can see we have a square bracket here. And in this case, it's y is less than or equal to 0. Y is an element of R, right? That's the basic stuff you got to know for this one. Okay, now, next one. Combining transformations. So what we got here is we got a quadratic, and this happens to be in what we call vertex form, right? That whole thing is vertex form. So when it's in vertex form, you can actually tell me the vertex right away. So look here, what number do I plug in here to make that 0? 5, so that's the x value of our vertex. What number is out here? Plus 4, so that's the y value of our vertex. Good, so we can plot that on the graph here, 5, 4. Now, a couple things. If you notice, it's negative 3. So we know this opens downward, and because that number is like 2, 3, 4, 5, it's really narrow, right? So you can see it opens downward and it's narrow. We're just sketching it in this case. But we know some other things. Okay, we got the vertex. We know the axis of symmetry is x equals 5, right? Because that's the value of the x one. Hey, if I were to ask you what if it's a min or a max, well, it opens downward. It's a maximum in this case of y equals 4, right? You can ask these questions. Domain and range. Now, if you notice, the domain is exactly the same one on the previous page. Negative infinity to positive infinity. You'll see that a lot in what we do in grade 11 here, that the domain doesn't change a lot. The range is always going to be different. It's not until we get to grade 12 that you'll really see a lot of domains changing. So the range in this case, remember, negative infinity all the way up to positive 4, including 4. So if you wrote it the other way, you could go 4 is less than or equal, y is less than or equal to 4. And I didn't write the other stuff in as like y is an element of R, but you can do that. Okay, next one here. Hey, what if they give you a graph and some points and you have to figure out what the equation is? Well, in this case, they give you the vertex, and they tell you that it goes through this point. The only thing they don't tell you is, hey, what's A? Does it open up? Does it open down? Is it positive or negative? And is it like a number or a fraction? Well, we know right away A has to be positive because you can see the graph right here. But they tell us some things. They tell us the vertex and a point. So here's the basic vertex form. So what we do is we can plug in here. Now the vertex is 2, 1. So for here, you have to realize we have to plug in x minus 2, because remember, what value do we plug in here to make this thing equal 0? Well, we plug in positive 2. Yeah, that's our vertex there. And then the plus 1 is on the outside. Okay, so now if you look, we got y, a, and x. Those are all unknowns. Well, they give us an x and a y. They give us a 4 as an x and a 9 as a y. It tells us it goes through those points. So what we can do is we can plug those into the equation. So 9 is my y, and my x is 4. And then you just do the math, right? 4 minus 2 is 2. 2 squared is 4a. And then 4a plus 1. How do you get rid of the plus 1? Subtract from 1 from both sides. We have 8 equals 4a. Divide both sides by 4. We end up with a equals 2. So that tells us now if you notice, these x and y's are back to x and y's. We just use them as a 9 and a 4 to do the work. But now we figured out what a is. So now we can actually write out your equation right there. Okay, last page. This one here is kind of interesting, and I mean, there's a lot of words here that goes with it, but basically the gist of it is when you're going through a graph, you have to realize, is there one intercept, x-intercept, two x-intercepts, or no x-intercepts? So my easiest way is, okay, stop thinking about, is it greater or less than this? Think about what it actually looks like visually. And if you sketch it out, it works too. So here we have y equals, or f of x equals 3x minus 2 squared. So we know our vertex, remember, what number do we plug in here to make it 0? 2. So our vertex is 2, 0. Good. And then we know it's right on the x-axis, because that's 2, 0, and it's a 3, but who cares that it's a 3? It's positive. So it opens up. So this is a sketch of what it would look like. You can see right away that it has one x-intercept. Way easier to do it that way. This one here, y equals -2 and then in brackets x plus 2 squared minus 2. Well, we know in here, yeah, what number do we plug in here to make this 0? -2. The y value is -2, so our vertex is -2, -2. Now, what's really important here is in the front, it opens downward. Who cares that it's a 2, right? Because that just makes it narrower, but it opens downward. So if you can see, this is what it would look like when we sketched it out. Well, this never crosses the x-axis at all, so there'd be 0 x-intercepts. We're going to get more into this in one of the later episodes when we talk about the discriminant, and you'll recognize that right away. But the same concept. Does it have one x-intercept, two x-intercepts, or no x-intercepts? Okay, that's the end of that lesson.